Hello everyone, I am Mrs. Ekute Bethel, and today in our video we'll be featuring the manufacture of sodium carbonate. At the end of this lesson, what are you expected to learn? It's expected that at the end of the lesson you should be able to state the steps involved in the manufacture of soda ash. You should also be able to explain in details the production process of soda ash and also write chemical equations showing the reactions involved in the Solvay process. So what is sodium carbonate? Sodium carbonate is a strong alkali base with molecular formula Na2CO3, and it's also known as washing soda or soda ash or disodium carbonate and calcined soda. But what are the applications of sodium carbonate? Sodium carbonate has versatile application. It can be used to prepare edible items. It can also be used to prepare non-edible items like soap. The edible items it can be used is used in the production of baking soda, which is used in the baking of cakes and some other flour made items. It can also be used in paper making and even in bleaching products. So having said that, on sodium carbonate, what are the sources of sodium carbonate? Sodium carbonate can be found in nature as constituents of mineral waters and also as substituents in solid minerals, or rather constituents in solid minerals like natron, like trona and thermonatrite. It can also be manufactured from common salt, which is sodium chloride, and limestone. This second source is what we'll be considering in this video: manufacture of sodium carbonate. Now, what processes are involved in the manufacture of soda ash? Two processes are involved. One is the Leblanc's process and the other Ernest Solvay process. But in industrial chemical processes as a course, we are concerned about manufacture of compounds in an industrial scale, and Solvay process fits in here because it is used in the industrial production of soda ash. So we'll be concerned with the Solvay process. Now, what does this involve? There are 5 steps involved in the Solvay process. The first step, as you can see from the chart, is the brine purification, followed by ammoniation of the purified brine, and then the carbonation of ammoniated brine to the formation of sodium carbonate and the recovery of ammonia. So let's now consider each of these steps to know what it involves. This flowchart summarizes all that is involved in the Solvay process. Remember, the first step we said it is purification of brine. Why purify brine? We purify brine because it contains impurities of calcium, magnesium, and iron compounds. So to remove these impurities, soda ash and lime are added to the brine solution to precipitate out these compounds as carbonates or as hydroxides. Now, after precipitation, the solution is filtered, and of course the brine is neutralized with hydrochloric acid and allowed to settle. Now, having purified the brine, remember our second step? Yes, the second step has to do with ammoniation of the brine. What does this involve? The brine which has been purified, ammonia gas is absorbed into it to form ammoniated brine. Now, this ammoniated brine contains 3 components, which is sodium chloride, water, and ammonia. And remember too that ammonia is very soluble in water, so the absorption will be complete. But now we have ammoniated the brine. What then happens next? That is step 3, which is carbonation of the ammoniated brine. This usually happens in the carbonating tower, as you can see, or we call that carbonating tower the Solvay tower. So what happens here is this: carbon 4 oxide gets absorbed into the ammoniated brine. But where does the carbon 4 oxide come from? It is gotten from limestone. When limestone is heated in the lime kiln, calcium oxide, which is quicklime, and carbon 4 oxide are produced. So the carbon 4 oxide from this reaction, or from the thermal decomposition of limestone, it's now absorbed into the ammoniated brine. Now what then happens is this: the ammonia, which has been dissolved in the brine, then forms ammonium hydrogen carbonate on absorption of carbon 4 oxide. You can see ammonium hydrogen carbonate sometimes written as ammonium bicarbonate. Then the ammonium bicarbonate now reacts with sodium chloride to form sodium bicarbonate, as you can see down here. After formation of ammonium hydrogen carbonate, it's filtered, and then the ammonium bicarbonate reacts with sodium chloride to form sodium bicarbonate. Recall too that sodium bicarbonate is less soluble than other components of the solution, so it then settles at the lower part of the Solvay tower, which is now separated by vacuum filtration and washed to remove ammonium salts. You can see ammonium chloride here showing the ammonium salt that is formed at the end of the reaction in the carbonating tower. Now, having formed sodium bicarbonate, remember it is sodium carbonate we want to get. So how do we get the sodium carbonate from the sodium bicarbonate? It is by heating sodium bicarbonate strongly at 300 degrees Celsius to yield sodium carbonate. But remember that when limestone was thermally decomposed, two products were formed. Now we've used the carbon 4 oxide in the carbonating tower. What about the quicklime, which is calcium oxide? What happens to it? The calcium oxide reacts with water in a lime slaker. You can see H2O and CaO pointing towards the lime slaker. So both of them react in the lime slaker to form slaked lime, which is calcium hydroxide. Now this calcium hydroxide then reacts with the ammonium salt formed from the carbonation tower, which is ammonium chloride, to yield calcium chloride, water, and ammonia gas. So by this process now, the ammonia gas which was used at first is recovered and then used for subsequent production. So you see that this is how we can produce sodium carbonate by the Solvay process. So thank you for listening, and please don't forget to subscribe to my YouTube channel if you enjoyed the lesson. Bye for now.